Welcome to video 2 of the 3-part PROFIS Rebar tutorial series. Please refer to video 1 if you need a refresher on getting started with the software. In this video, we will illustrate a wall-to-foundation design. First, select your country of design and choose your design standard. You can choose between Eurocode 2 and ACI codes. Select Wall as a new structure and Slab as the existing structure. You will see here under Standard Applications that there are 3 cases. The first case of overlap joint requires a hooked bar in the existing slab. In the second case, compression, the structure is subjected to compression only. And in the third case, simply supported, the system connection does not take up the bending moment. Then, in all applications, there are 2 cases. The wall-on-slab case is a moment-resisting connection based on the HIT rebar design method. The overlap joint requires a hooked bar in the existing slab. If you want to design a moment-resisting connection with post-installed rebar, wall-on-slab is the recommended option. The structure is now ready for you to input the dimensions. Scroll the mouse over the measure points and click to enter the desired values. Then, input the load. Then select your design type. Static design is assumed by default. The next step is to select your drilling method and base material. Then select the design method, and then the desired product. Now we have to input data to the existing structure. On the top tab, go to Existing Structure. Select the direction of cracks in the base material with respect to the direction of the post-installed rebar. Next, in the temperature section, you can input short-term, long-term, and installation temperatures. Input the main concrete cover. In installation conditions, choose the material condition and the drilling condition. Then move to the new structure and begin to input data for the top reinforcement. Input the concrete cover and bond condition. Then input the minimum reinforcement. This is the minimum reinforcement required by the design code. Next, do bottom reinforcement, inputting the concrete cover, bond condition, and minimum reinforcement. Then select shear reinforcement. If you select width, you have the option to input the inclination of the compression struts and of the shear reinforcement. Next, select HIT rebar design method. As with Eurocode 2, the solution with straight bars is not possible due to the hooked bars required. Hilti developed a unique design method based on the strut and tie model, which allows the design of moment-resisting connections with straight bars. Choose the product you're going to use. The software immediately provides a solution. Finally, you can print all the calculations in one click. You can create the design report, which includes all the designing information. The first and second pages include a 3D drawing of the system connection with the fastening points. In addition, it includes a summary of the parameters needed in the design: loads, drilling method and temperatures, material and safety, Eurocode 2 parameters, and post-installed reinforcement parameters, such as number of layers or top and bottom reinforcement parameters. On the third page, you can find a summary of the selected solution: bar size, drill bit size, bar spacing, distance center surface, drilled hole required. In addition, you can find required accessories for the installation. Since the accessories, such as drilling method or cleaning process, largely affect the design and the installation phase, in the design phase, it is very important to choose carefully the accessories required in the installation phase. Finally, you can find a summary of the section analysis, including theta angle, based on Eurocode 2 provisions, the inner lever arm, and position of the neutral axis. From now on, the report can be split into two sections: design of the post-installed rebar anchorage length on the tension side of the connection, and the design of the post-installed rebar anchorage length on the compression side. Let's start from the tension side section. A summary of the design input is followed by 5 paragraphs A, B, C, D, and E. Paragraph A summarizes the reactions in the node calculated per equilibrium. Paragraph B includes calculations of the post-installed rebar anchorage length based on the HIT rebar design method. For additional information on this section, please refer to Video 1. Paragraph C verifies the compressive strut in the node. It calculates the drill hole depth, taking into account the strut angle of the compressive strut in the node and the anchorage length calculated in the previous section. This angle must be between 30 and 60 degrees. The software verifies that the compressive stress transferred in the diagonal direction is equal or smaller than the compressive strength of the concrete. Paragraph D verifies splitting in the transition area. For equilibrium, the concrete is subjected to tension in the vertical direction. The software verifies that the splitting stress developed in the slab is equal or minor than the tensile strength of the concrete. Paragraph E calculates the additional reinforcement needed in the existing slab to take up the tensile action. The user has to verify if the reinforcement located in the node area required for forces, in addition to the previous loading, is able to carry this additional tension force. Here, the calculation on the tensile side of the node ends. The next section, called Lower Layer, calculates the post-installed rebar anchorage length in the compression side of the node. This length is the minimum anchorage length required by the Eurocode 2 for reinforcement anchored in compression zones. Together with the report, you can also link to the Hilti BIM CAD library. You can save this report to refer back to later and reopen the project from Profis. That's the end of Video 2 of the Profis Rebar tutorial series. Video 3 will cover slab-to-slab design. Don't forget that the Profis software you can link directly to Hilti Online and Hilti Online Technical Library, where you can access and download approvals. For further information, please don't hesitate to contact Hilti.